right now. And we're shared. Okay, Gene, whenever you're ready.
All right. This is circuit component. In what application? Oh, wait a minute, I got something here.
Are you joined on 2 devices?
Yeah, and that's what I'm trying to deal with right now.
Okay, it looks like you dropped the other one.
Yeah. Yeah, I'm gonna leave that one off for right now. Okay. In what application is gallium arsenide used as a semiconductor material? The answer would be C, in microwave circuits. 2, which of the following semiconductor materials contains excess free electrons? That would be A, N-type. 3, why does a PN junction diode not conduct current when reverse biased? B, C, holes in a P-type material and electrons in the N-type material are separated by the applied voltage, widening the depletion region. Chris, you don't want me to be reading every possible answer, right?
No, just the correct answers.
Okay. All right. Number 4. What is the name given to an impurity atom that adds holes to a semiconductor crystal structure? That would be C, acceptor impurity. 5, how does DC input impedance at the gate of a field effect transistor compare with the DC input impedance of a bipolar transistor? It'd be C, and FET has higher input impedance. 6, what is the beta of a bipolar junction transistor? That would be B, the change in collector current with respect to base current. 7, which of the following indicates that a silicone NPN junction transistor is biased on? Be D, base to emitter voltage is approximately 0.6 to 0.7 volts. 8, what term indicates the frequency at which the grounded base current gain of a transistor has decreased to 0.7 of the gain obtainable at 1 kilohertz? Be D, alpha cutoff frequency. 9, what is a depletion mode FET? Be alpha, an FET that exhibits a current flow between source and drain when no gate voltage is applied. Okay, the next one is 10. And this one's got a figure of symbols that you're going to have to identify. It says in figure E6-1, what is the schematic symbol for an N-channel dual gate MOSFET? And the answer to that would be B, number 4. Question 11, in figure E6-1, what is the schematic symbol for a P-junction FET? That would be A, 1.
Yeah, one thing I wanted to mention, for P channels, the little arrow is going to be pointing outward. And if we look back for an N channel, it's going to be pointing inward. So that's an easy way to tell the difference of the symbol.
All right, ready?
Go ahead.
Okay. 12. Why do so many MOSFET devices have internally connected Zener diodes on the gates? D, to reduce the chance of static damage to the gate. Okay. Section B. Number 1, what is the most useful characteristic of a Zener diode? It would be B, a constant voltage drop under conditions of varying current. 2, what is an important characteristic of a Schottky diode as compared to an ordinary silicon diode when used as a power supply rectifier? It would be D, less forward voltage drop.
Yeah, normal voltage drop is about 0.68 or 0.7.
Yeah.
So with the Schottky, it's much lower and it switches much quicker.
Okay, what type of bias is required for an LED to emit light? It would be B, forward bias.
Yeah, reverse bias, you don't get a whole lot.
Okay, number 4, what type of semiconductor device is designed to use a voltage controlled capacitor? It would be A, varactor diode. 5, what characteristic of a PIN diode makes it useful as an RF switch? D, low junction capacitance. Okay. They say number 6 was withdrawn. So we go to number 7. What is the failure mechanism when a junction diode fails due to excessive current? It would be B, excessive junction temperature. All righty, number 8. Which of the following is a Schottky barrier diode? It is going to be A, metal semiconductor junction. 9. What is a common use for point contact diodes? VC, as an RF detector. All right, we got another little drawing coming up again. Number 10, in figure E6-2, what is the schematic symbol for a light emitting diode? It is going to be B, number 5. That one's a kind of a common sense thing. I mean,
yeah, the arrows kind of give it away.
Yeah. I don't think it takes too much of a rocket scientist to figure that one out.
You are correct.
All righty, number 11. What is used to control the attenuation of RF signals by a PIN diode? A, forward DC bias current. Oh, this is section C, which digitalize. Okay, number 1. What is the function of hysteresis in a comparator. It's alpha to prevent input noise from causing unstable output signals.
If you ever were, interested in hysteresis, that's a term that comes from magnetism. And, basically what it means is in different directions, you get slightly different behavior. And that little gap between on and off, that's helpful because if you have noise, that noise could be within the range to actually trigger it to go off. So you'd have rapid switching between on and off. So the hysteresis helps out that it can help prevent input noise from causing unstable behavior there.
Okay, number 2. What happens when the level of the comparator's input signal crosses the threshold? V. Baker, the comparator changes its output state. Number 3 is tri-state logic. The alpha, logic devices with 0, 1, and high impedance output states. Number 4, what are the following is an advantage of a BIC-MOS logic? It is C. It has a high input impedance of CMOS and low output impedance of bipolar transistors. Okay, number 5. What is the advantage of CMOS logic devices over TTL devices? D. Low power consumption. Number 6, why do CMOS digital integrated circuits have high immunity to noise on the input signal or power supply? B. C. Charlie, the input switching threshold is about 1/2 of the power supply voltage. Okay, number 7. What best describes a pull-up or pull-down resistor? That's going to be B. Baker, a resistor connected to the positive or negative supply line used to establish a voltage when an input or output is an open circuit. Okay, number 8. In figure 6-3, what is the schematic symbol for a NAND gate? That is going to be B, number 2.
Yeah, if you look, number 1, that's going to be just an AND gate. And you notice the little circle up the front, that's the NOT operator. So the AND becomes a NAND with that.
Okay. Number 9. What is a programmable logic device? It is B, a programmable collection of logic gates and circuits in a single integrated circuit. Number 10. In figure E6-3, what is the schematic symbol for a NOR gate? It's going to be D delta number 4.
Yeah, same thing here. It's got that negative operator on it. 3 is an OR gate, so the little circle in front of it makes it into a NOR.
Okay, number 11. In figure E6-3, what is the schematic symbol for a NOT operation inverter? That would be C, number 5. Okay, This next section D is toroidal and solenoidal inductors. Number one, why should core saturation of an impedance matching transformer be avoided? It'd be A, harmonics and distortion could result. Okay, number two, what is the equivalent circuit of a quartz crystal? It's going to be A, motional capacitance, motional inductance, and less resistance in series, all in parallel with a shunt capacitor representing electrode and stray capacitance.
That's a mouthful.
Yeah. Definitely. Number three, which of the following is an aspect of a piezoelectric effect? And that's going to be A, it's a mechanical deformation of material by the application of a voltage. I want to make a comment on this. I'm a little more familiar with a lot of these. A lot of the electronics you buy these days have small piezoelectric sound devices in them. Those are the things that go beep or have making chirping noises and stuff like that, because a lot of people I don't think are aware where that noise really comes from. Okay, number four, which materials are commonly used as a core in an inductor? And that's going to be B, ferrite and brass. Number five, what is one reason for using ferrite cores rather than powdered iron in an inductor? It's going to be C. Ferrite toroids generally require fewer turns to produce a given inductance value. Okay, number six, what core material property determines the inductance of an inductor? That's going to be D, permeability. All righty, number seven. What is current in the primary winding of a transformer called if no load is attached to the secondary? That's going to be A, magnetizing current. 8, what is one reason for using powdered iron cores rather than ferrite cores in an inductor? It's going to be B, powdered iron cores generally maintain their characteristics at higher currents. Number 9, what devices are commonly used as VHF and UHF parasitic suppressors at the input and output terminals of a transistor HF amplifier? That would be C, ferrite beads. Number 10, what is the primary advantage of using toroidal core instead of solenoidal core in an inductor? A, toroidal cores confine most of the magnetic field within the core material.
You can see in this one down here, solenoidal, you're going to have those magnetic fields actually going outside of the solenoid. But within a toroid, the magnetic field's going to basically circulate within the toroid itself.
Okay. Number 11, what type of core material decreases inductance when inserted into the coil? That's B, brass. Okay, number 12. What is inductor saturation? It's going to be C, the ability of the inductor's core to store magnetic energy has been exceeded. 13. What is the primary cause of inductor self-resonance? It's going to be A, interturn capacitance.
Yeah, so in between each turn, there's a slight gap. And anytime you have that gap, you know, you have a little bit of capacitance. And next section.
Next section is E, 6E, analog ICs, MMICs, and IC packaging characteristics. Number 1, why is gallium arsenide useful for semiconductor devices operating at UHF and higher frequencies? It's going to be B, higher electron mobility. 2, which of the following device packages is a through-hole type? It's going to be A, DIP, DIP.
And what they mean by through hole is that the legs of the IC are going to actually go through the board, as opposed to a surface mount where everything is attached to pads on the surface of the circuit board.
Yeah, and that can be that can be really, really fun these days, because a lot of the surface mount, if you have to change one, it takes a lot of expertise to deal with that.
Yeah, I mean, I remember in college dealing with, you know, the regular dip packages. And, you know, there was always that concern that, you know, once you got it soldered in, you know, if you have to remove it, oh my goodness, that's, you know, 8, 12, 16 pins you're going to have to completely desolder. So sockets, you know, got to be real popular.
Yeah, and they do make some pieces of equipment that can take some of those higher numbered surface mounts and desolder them all at once, but it's extremely expensive, and you have to have, you know, a real need for that piece of equipment. Okay, number 3. Which of the following materials is likely to provide the highest frequency of operation when used as an MMIC? It's going to be D, gallium nitride. Okay, number 4. Which is the most common input and output impedance of circuits that use MMICs? It's going to be A, 50 ohms. Okay, number 5. Which of the following noise figure values is typical of a low noise UHF preamplifier? It's going to be A, 2 dB. Number 6, which characteristics of the MMIC make it popular choice for a VHF through microwave circuits? It's going to be D, controlled gain, low noise figure, and constant input and output impedance over the specified frequency range. All righty, number 7. What type of transmission line is used for connections to MMICs? It's going to be D, microstrip. And basically from what I've gathered with this microstrip is basically, that's just the printed circuit on the board is what's used rather than trying to use coax or other interconnecting wiring. Okay, number 8. How is power supplied to the most common type of MMIC? It's going to be A, through a resistor and or RF choke connected to the amplifier output lead. Number 9, which following component package types would be most suitable for use at frequencies above the HF range? That would be D, surface mount.
You know, part of the reason for that is that the leads, as short as they are in microwave range, they become antennas and can, you know, both transmit and receive. So surface mount, it's going directly, you know, onto the board. So you can pretty much eliminate a lot of that.
Okay, let's see. Number 10. What advantage does surface mount technology offer at RF compared to using through-hole components? It's going to be D. All of these choices are correct. And I'll read them off real quick. There's smaller circuit area, shorter circuit board traces. Components have less parasitic inductance and capacitance. Okay, number 11. What is a characteristic of dip packaging used for integrated circuits? D, a total of 2 rows of connecting pins placed on opposite sides of the package. It's a dual inline package. Okay, number 12. Why are dip through-hole package ICs not typically used at UHF and higher frequencies? C, excessive lead length. And I've seen some cases where that could be a problem because the leads stick through the holes in the board, and even those little pieces that stick through, if they're not trimmed properly, can actually act like little antennas. So that's something else you got to be very careful of. Okay. We're going into electro-optical technology, sections 6F. What absorbs the energy from light falling on a photovoltaic cell? That would be C, electrons. Number 2, what happens to the conductivity of a photoconductive material when light shines on it? A, it increases. Number 3, what is the most common configuration of an optoisolator or optocoupler? It's going to be D, an LED and a phototransistor. Okay, number 4, what is a photovoltaic effect? It's going to be B, the conversion of light to electrical energy. Number 5, what describes an optical shaft encoder? It's going to be a device that detects rotation of a control by interrupting a light source with a patterned wheel.
You know, the tuning knobs on most HF radios are have optical shaft encoders on them. That way they can spin kind of freely, and you've got a counter in there that counts the number of times that the photo sensor goes on and off, and it knows which direction you're turning to whether increase or decrease the frequency.
Okay, Now we go to number 6. Which of these materials is most commonly used to create photoconductive devices? It's going to be A, crystalline semiconductor. Okay. Number 7. What is a solid state relay? B, a device that uses semiconductors to implement the function of an electromechanical relay. Number 8. Why are optoisolators often used in conjunction with solid state circuits when switching 120 volts AC? It's going to be C. Optoisolators provide a high degree of electrical isolation between a control circuit and a circuit being switched. Number 9. What is the efficiency of a photovoltaic cell? It will be D, the relative fraction of light that is converted to current. Number 10. What is the most common type of photovoltaic cell used in electrical power generation? It's going to be B, silicone. And number 11, what is the approximate open circuit voltage produced by a fully illuminated silicone photovoltaic cell? It's going to be B, 0.5 volts. Okay, that ends section 6.
All right. Let's go through and do the practice questions. So we'll start with A. So in what application is gallium arsenide used as a semiconductor material?
C.
Anybody remember this one?
C.
C, yeah, microwave circuits. Which of the following semiconductor material contains excess free electrons?
It's either N or P.
Okay, so you can usually think of N is negative, P is positive. But by negative, it means it's a negative charge. So an electron has a negative charge. A proton or a hole would have a positive charge. So it's going to be N type. Why does a PN junction diode not conduct current when reverse biased? Okay, so this is going to be C. The holes in the electrons are going to be separated by the applied voltage and widening the depletion region. What is the name given to an impurity atom that adds holes to a semiconductor crystal structure? Okay, remember when you're talking about semiconductors and electrons, you're going to have donors and acceptors. The donor is going to be one that's going to want to give up an electron. An acceptor is one that's going to create a hole or be able to accept that electron. So that's going to be C. How does DC input impedance at the gate of a field effect transistor compared with the DC input impedance of a bipolar transistor?
B.
B Bravo?
Yes.
Yeah, higher input impedance. What is the beta of a bipolar junction transistor? I believe it's going to be C. No,
D.
D, change in the current. Which of the following indicates that a silicon NPN junction transistor is biased on?
Let me see.
B or C?
Yeah, it's gonna be both.
C. What term indicates the frequency at which the grounded base current gain of a transistor has decreased to 0.7 of the gain obtainable at 1 kilohertz?
Mhm.
Okay, that's going to be the alpha cutoff frequency. What is a depletion mode FET?
D.
C?
C.
Yeah, it's going
Just C.
to allow current flow. Okay, which is the schematic symbol for an N-channel dual gate MOSFET?
Number 4.
D.
D.
B, number 6?
No, D like dog.
Yeah,
D dog.
D. What is the schematic symbol for a P-channel junction FET?
C. B.
D
I
or
say B like in boy.
B.
I think it's number one in
Yeah.
the diagrams.
okay, I'm going to say it's number 1. And I guess correct. Why do many MOSFET devices have internally connected Zener diodes on the gates?
A. Alpha.
Yeah, that's
C.
it's gonna be A.
Yeah, reduce the chance of static.
Okay. What is the most useful characteristic of a Zener diode?
Ooh, B.
Yeah, B.
Yeah,
B.
B. What is an important characteristic of a Schottky diode as compared to an ordinary silicon diode when used as a power supply rectifier?
A.
B.
Yeah, that's going to be a lower forward voltage drop. What type of bias is required for an LED to emit light?
Forward. A.
Yeah, a forward bias. What type of semiconductor device is designed for use as a voltage-controlled capacitor?
D.
B.
D.
B or D?
D.
Delta?
Yeah, yeah, delta, the third
Delta.
half.
What characteristic of a PIN diode makes it useful as an RF switch?
A.
No. C. No.
B.
Looks like low junction capacitance.
That's not on the test.
No. Is that the one that got dropped?
Hopefully,
Which of the following is a common use of a Schottky diode?
B like Charlie. Oh, shoot.
A.
Let's see.
A,
A?
A,
Yeah.
Correct. Yeah, that's a Xena diode I was thinking of.
Yeah. What is the failure mechanism when a junction diode fails due to excessive current?
Ooh, that's temperature.
D.
D.
Yeah. And usually the magic smoke comes out.
The genie's out of the bottle.
Yeah. Which of the following is a Schottky barrier diode?
A,
A, yeah.
Yeah, A. What is a common use for point contact diodes?
D.
D.
RF.
D is in Delta?
Yes.
Yeah,
Yeah, is an RF detector. A. What is a schematic symbol for a light emitting diode?
B.
number 5, B.
Yeah, that kind of gives it away.
Yeah, right.
If
We
you
don't
get that one, if you get that one wrong, you can
Yeah.
forget.
Hey, you better get up and walk out.
What is used to control the attenuation of RF signals by a PIN diode?
B like in boy.
B.
Oh, shoot.
It's gonna be A.
Forward.
A. Yeah, for DC bias current. Okay, not too bad. Let's go on to C. Okay, what is the function of hysteresis in a comparator?
P.
Bravo, Charlie,
No, C, Charlie.
Charlie.
C, Charlie.
Yeah. What happens when the level of the comparator's input signal crosses the threshold?
Check, alpha.
D.
Alpha.
Yeah, alpha. What is tri-state logic?
B.
B.
Yeah. B. Which of the following is an advantage of a BICMOS logic?
C.
C, yeah, because it's a combination of bipolar and CMOS. What is it?
Chris, that's how you pronounce that, is Bic Moss?
That's how I've always pronounced it.
Really? Okay. I thought it was.
I may be
Bic-
completely wrong.
Yeah.
Okay, what is the advantage? What is an advantage of CMOS logic devices over TTL devices?
Power consumption.
Yeah, lower power consumption. By TTL, that's short for transistor logic. And those are built or used to be built with bipolar transistors. So, you have to supply current for those to switch. With a CMOS logic device, all you need to do is apply a signal. So D, lower power consumption. Why do CMOS digital integrated circuits have high immunity to noise on the input signal or power supply? Okay, this is gonna be, I believe, delta. That's just gonna be one you're gonna have to memorize. What best describes a pull-up or pull-down resistor?
It's gonna be B.
Bravo. In figure E63, what is the schematic symbol for a NAND gate?
It'll be C. 1.
To D.
D? Yeah, delta.
Okay.
That's gonna be, number one is gonna be an AND gate with a little negation operator on there. Number two is gonna be NAND. What is a programmable logic device, or PLD? Yeah, it's gonna be alpha, programmable logic, collection of logic gates and circuits in a single integrated circuit. Okay, in E63, what is the symbol for a NOR gate?
Be like in Baker.
Yeah, that's an OR. Number three is an OR. Number four is an OR with a negator, so that becomes a NOR. So B. In figure E63, what is the schematic symbol for the NOT operation or an inverter?
Alpha.
Yeah, it's gonna be alpha. All right, we rocked on that one.
We don't have to figure out the circuit, just get by the diagram.
Okay, why should core saturation of an impedance matching transformer be avoided?
D.
C.
C, it would seem like it, but you would actually have to pass saturation to start changing the permeability. It's going to be D, harmonics and distortion
Okay.
could result. What is the equivalent circuit of a quartz crystal? Okay, if you remember this one, it's an inductor, a resistor, and a capacitor all in series, and then that's in parallel with another capacitor.
So B.
B.
Yeah, so B. Which of the following is an aspect of the piezoelectric effect? Yeah, remember, like Gene said, these are used for buzzers.
B.
Yeah, so if you apply voltage to it, the physical, crystal is going to deform. So by switching that voltage on and off at a rate that puts it within hearing range, that becomes a buzzer. Which materials are commonly used as a core in an inductor?
It's going to be B.
B.
Yeah, ferrite and brass. What is one reason for using ferrite cores rather than powdered iron in an inductor?
A, alpha.
A. Yeah.
Yeah, it's going to be alpha. The ferrites have fewer turns to produce a given impedance, but an iron core can handle much stronger magnetic fields or much higher voltages.
All the power transformers use iron, steel.
Right, exactly. All right, what core material property determines the inductance of an inductor?
That's A.
Yeah,
A.
permeability. What is current in the primary winding of a transformer called if no load is attached to the secondary?
D, like in dog.
D dog.
Yeah,
Yeah.
if you don't have anything attached to the other end of it, all it is a magnet, an electromagnet.
Yeah, it can be 10 times the power normally, but it's only for like nanoseconds.
Yeah.
That's my power theory coming out.
What is one reason for using powdered iron cores rather than ferrite cores in an inductor?
C.
Yeah, they're going to maintain their characteristics at higher currents. What devices are commonly used as VHF and UHF parasitic suppressors at the input and output terminals of a transistor HF amplifier?
D, ferrite beads.
Yeah, ferrite beads. What is the primary advantage of using a toroidal core instead of a solenoidal core in an inductor?
B,
D.
D.
Delta, yeah.
Delta. What type of core material decreases inductance when inserted into a coil?
Brass.
D, brass.
Yeah, brass. What is inductor saturation?
B.
B, Charlie.
B,
Charlie?
I mean B, boy.
Yeah, B,
I said
Bravo.
B, I said Charlie.
What is the primary cause of inductor self-resonance?
B, like in boy.
Yeah.
Yeah. Yeah, there's capacitance between turns. All right. I think we have two more sections.
This one.
Why is gallium arsenide useful for semiconductor devices operating at UHF and higher frequencies?
D,
Hmm,
D. Lower voltage, junction voltage, wow. And it would have to be A.
that's higher electron mobility. Which of the following device packages is a through-hole type?
A,
Yeah,
Yeah.
dual inline package. Which of the following materials is likely to provide the highest frequency of operation when used in MMICs?
Man, I want to say A, but I think it is silicone something.
yeah,
You were right with A. It's a gallium nitride. Which is the most common input and output impedance of circuits that use MMICs?
D, 50 ohms.
Yeah,
Yeah.
50 ohms. Which of the following noise figure values is typical of a low noise UHF preamplifier?
A.
Yeah, A, 2 decibels. What characteristics of the MMIC make it a popular choice for VHF through microwave circuits?
A,
Yeah,
A.
A. What type of transmission line is used for connections to MMICs?
D.
Yeah, D, microstrip. How is power supplied to the most common type of MMICs? It's going to be C.
C, yeah.
Which of the following component package types would be most suitable for use at frequencies above the HF range?
B,
D.
B like boy.
Surface mount. What advantage does surface mount technology offer at RF compared to using through-hole components?
all of the above.
Yeah, all of the
Yeah,
above.
all of the above.
What is a characteristic of dip packaging used for integrated circuits?
A,
Be A.
Yeah, and 2 rows of connecting pins. Why are dip through-hole package ICs not typically used at UHF and higher frequencies?
Too many pins. D.
Yeah, excessive lead length. All right, last section. What absorbs the energy from light falling on a photovoltaic cell?
electron.
The electrons.
Yeah, electrons. What happens to the conductivity of a photoconductive material when light shines on it?
So,
Yeah, it's doesn't it's increases. What is the most common configuration of an optoisolator or optocoupler?
Be C.
Yeah,
Yeah.
see. What is the photovoltaic effect?
A like alpha.
A.
Yeah, A. Which describes an optical shaft encoder?
B,
B.
Yeah,
B.
bravo.
The wheel.
Which of these materials is most commonly used to create photoconductive devices?
A.
Yeah, crystalline superconductor. What is a solid state relay?
C.
Yeah,
Yeah,
that's
C.
just a solid state version of an electromechanical relay. Why are optoisolators often used in conjunction with solid state circuits when switching 120 volts AC?
C,
C.
Yeah, you're going to have good isolation. What is the efficiency of a photovoltaic cell?
D,
D.
Yeah, it's just, what fraction of light is getting converted to current? What is the most common type of photovoltaic cell used for electrical power generation?
D.
D, silicon.
Yeah, silicon. What is the approximate open circuit voltage produced by a fully illuminated silicon photovoltaic cell?
C.
half a volt.
Yeah, half a volt. All right. That is it.
Guys, I got a little story to tell you about when I first got out of school. I was working on some offshore platforms, and I went out there, and the guy said, "Look, we had a man come in to troubleshoot this relay board that was used for logic stuff." And he said, "Make sure you know what you're doing." I said, "What do you mean?" He said, "Well, the last guy came out there, he pulled pulled a little relay out the circuit, the socket, and he listened to it. It didn't click when he shook it. So he figured the contact was frozen or something. He threw 100 and something of those relays into the Gulf of Mexico, and he was fired the next day because they were all electronic relays that didn't click." They didn't click once, but he could have found the right one if he tried to do it with, some kind of instrument. But he said it didn't click when he shook it, so it was no good.
That's an expensive mistake for sure.
That was it was in the early 70s when the Westinghouse was coming out with a Digilogic system, and it was like a plug relay. It looked just like a electromechanical relay, but it was all electronic, Then he threw all the 100 and something of those in the Gulf.
Well, did we have any other questions before I shut down recording?
Chris, I got one question about the, how you're looking at these tests from QRZ
Yes.
went over. What percentage of, say, right answers or whatever should we be shooting for? I know 100% would be, natural, but to feel like we're very comfortable at passing that action, what do you think would be the best percentage to be getting at?
I would, I would be trying for between 85 and 90%.
Yeah, because I've been that's one of the things I've been constantly going over these different sections. And, some of them I've done very well on. A lot of them I've gotten to 50% very easily, but there's naturally, the more I go over them, the better I get at each one of them.
Yeah. And, flipping through through the study guide, because all you're seeing are the right answers. The more you see those, the easier it's going to be when you take a practice exam or the real exam, and you're going to recognize that answer immediately.
Right.
So, that's the reason for going with, the question and just the correct answer. It helps eliminate those distractors, and, when you sit down and see it, you're going to know it a lot quicker.
Yeah, Roger's on that. I definitely have noticed that there's a couple of them that I didn't know answers to initially, and the more I got to being able to see that answer, it made it easier to answer the question.
Yeah, and as you said, with anything, repetition is key. The more you go over these, and you don't have to kill yourself over it, but spend a half an hour going through the next section each night, and then start taking practice exams, or at least practice sections like that. And as you keep repeating that, you're going to get better and better.
Yeah, I was feeling pretty good up until last week and this week. I'm a little shaken right now, kind of questioning my life choices. But
Yeah.
up until last week, I was feeling pretty good. Like I said, last week and this week, I'm kind of.
Yeah, these are definitely the more technical ends of the sections on the exam. They'll probably require the most study. But it's within grasp. I've seen some real idiots get their extra, so I'm confident you guys can make it.
As Jim Carrey said, so you're saying we got a chance.
Yeah, I was like, wait, I think I called the real idiot. Awesome.
All right.